for that lovely introduction. And definitely the right people are here today. I want to thank Alicia and the other right people via Tech Center for putting together this program and congratulate them on another great year. In spite of sort of being camped out, we keep talking about the new space. It is going to be beautiful, but they've been a bit in between spaces, so they've done astonishing work given their physical locale. But let me focus also on our speaker and on today's program. We're very fortunate to have speaking today Katie Salen. Katie is Executive Director of the Institute of Play and also Associate Professor in the Design and Technology Program at Parsons, the New School for Design. She's a co-author of Rules of Play, a game design fundamentals book, and she's co-author of the Game Design Reader. She's currently working as lead designer on a digital game that's designed to teach game design to middle school and high school youth. She also, this is maybe one of the more interesting factoids to me, and I'd like to hear more about this one especially at some point. She's leading a design team to create a game-based public school, the Game School. It's scheduled to open in fall 2009, starting with the 6th grade class. Other things that Katie engages in is serving as editor for a volume on the ecology of games for the MacArthur Foundation series on digital media and learning. She's co-editor of the International Journal of Learning and Media. She has been an animator on Richard Linklater's animated feature Waking Life. And she writes extensively on game design, design education, and game culture, including some of the first dispatches from the previously hidden world of Machinima. So Katie. Oh, and her title is, Systems to Think With, Games and the Architecture of Persistence.
Good morning. How is everybody? Good. Well, I wanted to thank Alicia for the invitation to come and speak. I think you contacted me months ago, so I had a long time to think about it. So long that I forgot what the title of my lecture was that I sent in. So I am going to talk about the same general thing. So Sue mentioned a couple of the projects that I'm working on right now, and what I wanted to do today was to talk about two in particular. One is the school called the Game School that I'm working on, as well as a game to teach game design to kids called Gamestar Mechanic, and I'll do a demo of that to you as part of this presentation. But I wanted to give you a little bit of a background. I am a professor at Parsons, and I teach in a program called Design and Technology. And it's a large graduate program, and students produce design-based work around narrative. They do animation, digital cinema, they build social software, they build games, and they work in an area called physical computing, where they work with motion sensors, sound sensors, and they're working at the connections between physical world space and virtual world space. So on a daily basis, I'm immersed in students sort of designing the kinds of things that they are actually working with in their downtime. And it's a very exciting space to be in, but in the last year, I entered a new kind of space, which is the space of secondary education, which is a new space for me. And it came about because I've been studying games for a number of years. My background is really in game design, and I've been trying to understand the way that games work. And in doing that, I began to realize, as many others have, that there's a really strong connection with how learning works. And in looking at those connections, began to imagine that perhaps there was a way to take our understanding of how games worked as interactive systems and turn that into a kind of pedagogy, and turn it into a framework for the design of other kinds of systems that are not necessarily games, but maybe game-like, and deliver kinds of experiences that games do. So the two projects that I'm going to talk about really try to connect real-world spaces. So when I talk about games, I'm not just talking about digital games. I'm also talking about non-digital games, social games, paper-based games, as well as connections to learning. And we're looking at work within formal learning spaces like a school, as well as informal learning spaces. And I imagine that a lot of work that you guys are doing is grappling with this question of how do we leverage things that our students are doing outside of class. When we started the school project, this is a project that is being produced in partnership with the largest school reform organization in New York called New Visions for Public Schools. We thought the question we were asking is, what is school? And so we started down that line of inquiry for a while, but we immediately realized that the question that we really needed to be asking is, where is school? And that question came about because we started doing ethnographies of, this is of my nephew, who's 13 years old, and of some of the young people that we were working with. And we realized that their lives of learning spaces perhaps looked very different than we might have imagined that they looked like even 5 years ago. And what we began to think about is that when we ask the question of where is school, what we're recognizing is that there are all kinds of learning environments that kids are engaged in, and that we need to begin to find ways to validate the kinds of learning happening in those spaces, and in particular in the design of a new learning institution like a school, begin to figure out how to create connections between learning spaces that may traditionally have appeared external to school and those kinds of experiences that are happening in school. So our model for thinking about school is much more about in-school space is just one node within a set of learning spaces that kids are moving across and navigating through. And that our experience of design is much more about finding ways to connect to these spaces rather than designing the single spaces themselves. So we've moved really towards a model of kind of navigation and connection. 4 particular drivers of change have been influencing this work, and I'm really coming to you today as a person in the midst of asking lots and lots of questions. We don't have answers for all of this work that we're doing, but we are beginning to build some frameworks and some theories about what we think is valuable. And one thing we think is valuable are these 4 kinds of drivers. We've been looking in particular at this issue of the sociability of learning, and as we've been working with young people, we're recognizing that more and more they learn through peer-to-peer networks, they learn through their friends, and they learn through community-based work. When I go to schools, and I've been visiting a lot of schools recently, there's not a lot of social stuff happening in the classroom, right? Kids are still treated as sort of an individual in a seat. You're not supposed to be talking to each other. There's no passing of information. So in some sense, there's kind of a big disconnect between the way, again, kids are learning outside of school spaces and in school spaces. So we've been looking at how do we leverage the social conditions that really are feeding learning in some of these external spaces. Networks of information, and I imagine this is a big one that you guys are engaged in, that kids today have access not only to networks of data, but also networks of human resources, ways to find connections to people who may know something that they need to know or have something that they really want to get. And that ability of kids to sort of move across complex sets of information networks is something new. Participatory convergence culture, so I know Henry Jenkins spoke at this conference maybe a year ago or 2 years ago. This is something he's been talking a lot about, the fact that young people today are really within a culture that's requiring participation of a different kind. And that participation often talks about a convergence of media, so kids moving back and forth between blogs and video and developing music, as well as productive culture, so kids are producing things. And then the last driver of change, which is an area of my interest, is games. And again, when we're talking about games, it's not just digital games, non-digital, pervasive, and mobile. One of the big things that I've been focusing on recently is this idea of, when we look at kids gaming in particular, what is it that they now have access to that they may not have had access to in other kinds of interactive experiences or non-interactive experiences? And one thing that we're discovering is that there's a kind of literacy around data that kids are developing because of the way that games handle data. And we often now talk about games as data-rich learning landscapes. So an example, this is a game called Dance Dance Revolution. Has anyone played? DDR? Couple. So this is a game that started in the arcade. It's a beat matching game where a musical score sort of floats across the screen and you have to dance and step on the beat. What players immediately started doing was creating visual scores of the dance steps, creating data representations, uploading those, and sharing them within a community for other players to download, memorize, and then build routines around. Okay, so the idea that 11-year-olds are building visual scores that look like this is pretty impressive. The fact that they're understanding how the system of that game works, because understanding the system is a way for them to be creative within it. This is a screenshot from World of Warcraft, and what you should pay attention to is not the characters moving through the space, but the amount of data that's part of the interface. So players in WoW construct and use customized widgets that they then bring into the interface that allows them access to different kinds of data about the game. To play a game means to be very concerned with your performance within that learning space. So kids and players themselves are finding ways to make their performance, their assessment, more clear to them. And in fact, what you're doing when you're playing a game is often looking through a data-rich interface. And this, I think, is again quite remarkable that young people today have the capacity to understand the complexity of this interface and also to begin to build some of these kinds of widgets. Another kind of literacy that we see within these landscapes is really around collaboration and around collaboration via mobile tools. So this was a game designed a couple years ago by a group in New York called Area Code, and it was a game for high school students that was played, I think, in 12 cities around the nation. It was a game using cell phones, and they were capturing territory, and they were using the cell phone to take pictures of things called semicodes. And if you look on the t-shirt, that's an example of a semicode. It's a visual barcode. And these semicodes were embedded in the environment. And kids were working in teams. They had headsets, so they were having to collaborate and communicate across time and space to kind of coordinate their activities to capture locations within the city. And this is, again, leading to a new way that kids are thinking about collaboration. Kids within that team had very particular roles. So we've been looking at the issue of working in cross-functional teams and how technology not just gives kids access to these kinds of experiences, but also allows them to perform in very particular ways. And then building on that collaboration, this is a screenshot from the 5th and 6th graders that I've been teaching game design to. We've been noticing that a lot of schools have one-to-one laptop initiatives and that it changes the way kids in the classroom interact with each other. So these kids are social, they're collaborative, they see the technology simply as a conversation tool, as a design tool, and they're constantly moving their laptops back and forth between each other, collaborating on design, discussing design, really leading to a kind of organic design process. Another kind of revelation that we had in a way that's been helpful for us talking about the work is that good teachers act like good designers. So we've often been talking about like good games act like good classrooms, but we actually think if we can get teachers to think of themselves really as designers, that creates a much stronger connection between this dialogue around use of new technologies, use of new media. A lot of teachers, and particularly in the secondary space, feel very nervous about new technology. They don't understand that it, in some sense, structures itself in a way very similar to the way that they might already structure their lessons. So if we talk about how a good designer might design a game, for example, the game creates a need to know in a student, same thing that a teacher does. Poses scaffolded challenges. This is one of the things that I think that games do very best, is that they really move a player through a scaffolded space, anticipating always what it is that they need to know at that particular moment, creating a kind of challenge that is just out of reach, and giving them an opportunity to try to achieve that challenge. Games, as well as good teachers, create context rich with feedback. The World of Warcraft example, again, is all about feedback around performance. And then creating cyclical opportunities for revision and reflection. This is one of the very first things people working with technology began to realize, is that digital technology allowed you to make mistakes, and to make mistakes in a low-risk situation. And one of the reasons we're seeing kids today producing so many things is that they have the ability to produce something that kind of sucks, get some feedback on it, revise it, and make it better. And it is actually expected that some of the very first things you do are terrible. And this, I think, is a change in culture, and it needs to be a change in culture from the perspective of the teacher as well. That we should stop looking for perfection in the students on the very first try, and rather begin to think about, well, how do we create opportunities for revision and reflection along the way. So one manifestation of this work has been, as I mentioned, working with young people in doing game design. And last summer, I had a chance to teach a week-long design camp for high school students with a lead programmer on the game that I'm going to be talking about named Eric Sokolowski. And we worked with, I think it was 12 high school kids for a week. And we met them from 8 in the morning to 4 in the afternoon. And they spent the week designing games. And they designed digital games and also non-digital games. And what we wanted them to think about is how do you take a kind of learning that happens in the digital space and translate that into a kind of design and learning that happens in an offline space. I'm just going to show you a short video here of some of the outcomes of that week. And what I want you to try to pay attention to is the way that the kids are talking about their process.
The green ones are the attackers. These are the defenders, and these are the smaller medics. These should be like right here, probably. And the defenders will be like all around them because they don't want the leader to die.
Right, so fencing, there's ways of moving, and there's very specific rules about you just touching someone for a kill, right? It's not actual, like...
I had no idea of how much work it takes to make one game.
I can't think right now because my brain is minded.
You need to know a lot about how people behave. You need to know about cognition. So game design is a very complex endeavor.
Very interesting.
I think
Are those still set on super strong enemies, by the way?
it should be.
Set the speed slow. I want to see how that feels. I want to make this this plus stronger. It can be super strong because they're gonna get hurt, and we don't know how much they're gonna get hurt. But I mean, that gives them all 4 tries to do it, which gives them enough tries to figure out how they need to do it.
This is too hard.
I beat it.
Oh, other than
Before coming to the workshop, I actually wasn't that excited because I thought it would be a lot of computer design and a lot of programming. And maybe it was just my bias and misconception about what game design is about. But I had those ideas before coming here, and what I saw was completely a very different thing.
Very self-explanatory. You can say, hey, there's a wrench there, you use it. It's pretty easy. Usually there's a little thing, and I drag, I want brick here, I want it to start here, I want this here, I want these here, you know.
This is what we did, actually, yeah. Like as a class, we did a big game of it.
So this exercise is partially to help you guys translate between digital and non-digital.
Think about what each of the pieces in the games are doing and how they're interacting with each other. So if you're an enemy, then you have to move exactly like the enemies move in the game. If you're an avatar, you'll have a little bit more free will. So when an enemy dies in the actual digital game, what happens? Disappear, right? So what's the best way we can disappear? This one has a lot of solid blocks that we can just lay down, and there's a lot of enemies who are moving around, 2 gold blocks and 1 avatar. This one also has a lot of enemies. This one is much more about sort of the layout of the space. Gravity. No gravity, no gravity. One rule, I think, that we already established last time, which is that you can't dodge, right?
Gaming can be many things, and to produce games you don't need to have like a huge infrastructure, you don't need to have a super expensive studio. They were creating games without the need to have materials, you know, it was just their imagination and working in teams.
It takes a lot of dedication and like a lot of hard work. It takes a long time.
So one thing that we were discovering in doing this kind of work is that when we first talk about the work, people often think that we're only talking about new media literacies. We're only talking about 21st century skills. And what we're discovering is that when we talk about games in particular, games are really good at bridging old literacies and new literacies. Games, when you create games, you often have to do a lot of writing. You often have to do a lot of sort of math, particularly when you get in the programming part of it. And it's sort of seamlessly connected together. So in the school that we're designing, we're beginning to think about what are sets of kind of bridging literacies that we really want to emphasize in the school to call attention to the thing that games do really well. One of them is systems thinking. And this is actually the big idea for the school, and for years the big idea that I think games really bring to the table is that when you design a game and when you play a game, one thing that you're really getting good at is understanding how systems work. And we think that understanding how systems work is a pretty important way to think in the 21st century. And it's not just thinking about how games work, but about how larger kinds of systems work as well, whether it has to do with the economy, whether it has to do with cultural systems, social systems, whether it has to do with your peer group in high school. And that giving kids the ability and the tool sets to really think in systemic ways is going to really prepare them for work in the 21st century. Designing play is another big idea that we're working with. A lot of people talk about having kids play games as parts of learning. We think that giving the kids opportunity to create games is an even stronger way, potentially, to begin to push on content issues, to begin to push on different kinds of literacy issues, and you saw that example in the video. Intelligent resourcing is a kind of literacy, a kind of practice that just refers to the fact that kids today don't need to know everything, and that we need to stop thinking that all of the knowledge needs to be in their head. And what we need to be able to do is to equip them to find the information that they need, whether that information is in online spaces, in library spaces, or whether it's in other human beings. So when we talk about intelligent resourcing, it's helping kids develop the skills to understand what they know, what they don't know, and how they can get the answer to the things that they don't know. Producing meaning goes back to this idea of participatory culture, where we really think that we want kids to be able to be expressive and to produce kinds of work that demonstrates their understanding and ideas of content, and also sort of broader ideas. And then tinkering is an idea that's sort of coming back from Dewey. The idea that you would, again, give kids kinds of spaces for them to mess around in, to test out ideas, to theorize. And you begin to scaffold that tinkering space in such a way that they're ultimately going to get to where you want them to go, but you give them the time and space to sort of move around and test out ideas. One other big idea of the school related to these bridging literacies is that in addition to asking the question of where is school, we had to ask the question of how does the 21st century organize knowledge? And certainly in the 20th century and beyond, we began to think about ideas that knowledge is organized around disciplines, around math, around science. You go to an English class, you go to a social studies class. And in looking at our model of games don't organize knowledge in that way. They organize knowledge in interdisciplinary ways where players are required to synthesize different kinds of domains around situated problems. And we felt that for the school that we needed to organize knowledge in those ways as well. We began to look at kinds of sensibilities, dispositions, ways of thinking and doing as structures to organize our knowledge domains. So this is a draft that will change, but I will share it with you now. These are the knowledge domains for our school. So the school is going to be a 6th grade through 12th grade school, and kids aren't going to take a class called math, for example. They will take a course called The Way Things Work. Okay, and this is an integrated math and science domain that has kids taking systems apart and putting them back together. They will take a class called Code Worlds, which is a math ELA synthesis class that looks at the idea of symbolic systems, how mathematical writing systems are similar to language writing systems in foreign languages. So if you give kids access to thinking about language in systemic terms, math is language, English is language, Spanish is language, then you give them a way of thinking about symbolic representation. We have a course called Being, Space, and Place that looks at connections between the individual, the community, and notions of geography, sort of time and space. And the idea is that in these integrated domains, kids are given challenge-based problems to solve. You throw them into a complex situation, you scaffold their movement through that problem, allow them to go deep into particular content, and then you let them theorize and achieve kinds of proposals for how to solve that complex problem. They'll be working collaboratively as well as individually, and they'll be making games as part of what they're doing. The four conditions that we've been really looking at in delivering this curriculum goes back to what I said about good teachers connecting to good game designers. We realized that to make this curriculum engaging, powerful, and relevant to kids, the first thing we have to do is create a need to know in them. One reason that we see so much production and so much interest in some online community spaces is that kids really have a need to know something in those spaces. They have to figure out how to blog. They have to figure out how to get through a level of a game. They have to figure out how to do something very specific in the video that they're wanting to do. If we don't create a need to know in them, if we don't situate the problem, then they're sort of just doing an exercise in school. A need to share goes back to this idea of the sociability of learning. We realize again that you can expand the ability and the knowledge base of a kid if you give them an opportunity to share what they know. And in sharing what they know, they become teachers for other kids. So it goes beyond just peer-to-peer sharing of information to really sharing of knowledge and how I solve that problem. An occasion to share, this is one thing I've noticed that teachers, and I do this myself, sometimes forget to actually build in, is that you may want your kids to share, but if you don't actually build an infrastructure in some of the tools that you're creating, for example, that sharing is not going to happen. And then the last thing is the idea of cross-channel context. We're finding that kids need the ability to disseminate and share across a variety of contexts. So it's not that it's just sharing in the classroom, but they need, for example, to be able to post something that they've made in your class to some of their external sites that they may be part of, whether it's YouTube, maybe it's a specific interest-driven site that they're part of. But you need to give them the abilities and build in an infrastructure to allow for that dissemination in multiple contexts. So the last thing I want to talk about is this game that I've alluded to called Gamestar Mechanic. And I, for about a year and a half, was lead designer on this project, and I've since stepped down now that it's in what's called closed beta. This was an interesting project. It was a collaboration between a game development studio in New York called Game Lab, a set of learning scientists from University of Wisconsin-Madison and a group led by Jim G. And it was funded by the MacArthur Foundation in their digital media and learning initiative. And they were asking questions about what new learning environments might look like for kids today. And we made a proposal to them that we think that a learning environment that taught kids how to design games could be a model of that kind of learning environment. So the idea that came out was this game called Gamestar Mechanic. It's designed in a sort of anime style. The guy in the bottom corner there is named Samson. So this is a game that's set in a narrative world. It has a social network component plus a game editor that allows kids to make games. And the story of the game is that there was a world called the Factory that used to run on games, and everything in the game was a game piece. And Samson was the head of something called the Council of Master Mechanics, and he had a brilliant idea one day to challenge the world to design the perfect game. And in doing so, they could reach no consensus, and the world ended up splitting into 6 different schools of games. And each of these schools of game had a particular philosophy about what they thought the perfect game was. So Samson is annoyed because 2 of the schools have fled the world. The world is really falling into disrepair. Games are broken. Nobody's making new games. So he decides to recruit kids from the outside world into the game to come in and be game mechanics. So this is the role that kids in the game take on. They've been recruited in. They're being given a job. They have to learn how to be a game designer in order to bring the world back to its formal splendor. And in doing that, it's a bona fide game. They're earning experience points to level up to become a member of the Council of Master Mechanics. And they earn points by making games, sharing games, reviewing games, playing games, all of the things that a game designer does. And David Schaefer talks about this idea is epistemic games, where a kid can take on a kind of profession. So in Gamestar Mechanics, kids take on the profession of game design. This is a sort of overall ecology. You come in as a player. You begin to take on identity as a kind of avatar. You then have a chance to move into a challenge map or a quest map. So the scaffolded kind of curriculum of this game is moving through a series of design quests. To solve a quest, you have to build a game or repair a game. That game then gives you a set of creatures or sprites that you then can use to build other games. So it's a game based on collectability, so you're growing your inventory over time. You then have a chance to share that game with others in the community and rate and review, and then you come back and start making games again. One of the big ideas of the game is that it uses a kind of method of teaching that is really specific to programming. And some of the early uses of games were around teaching kids how to program, giving them sort of IT skills. And in teaching kids how to program, one thing that they learn how to work with often are level editors, or the idea of manipulating variables within a system. So Gamestar Mechanic is not a game design program where kids have to do programming, but it does model a kind of thinking that programmers use in the sense that you have a chance to manipulate variables. And I'll show that to you in a second. So here's a sample of a screen. So every sprite that you add to the screen, you have a chance to go inside their sort of DNA and make decisions with these sliders around their speed, how much damage they do, what their movement style is. And it allows kids access to the underlying rules of this system and allows them to make choices within it. They have a chance to modify broken games. So this is one of the earliest challenges that they might go in. They click play, they try to move around. I'm sorry, you can't see this very well. And they eventually realize there's no way for them to get to the goal block. And then they have to figure out, well, what is it that I need to do this game to modify it to make it a real game. And so then they have a chance to move blocks around or erase some things. There's a big push in this game towards narrativity. So kids have a chance to work with a number of different backgrounds. There's lots of opportunities for writing. We've seen kids build 50-level games telling stories just using the level intro and level outro screens. And again, that goes back to the idea of kinds of bridging literacies that kids who traditionally have done very poorly in writing, don't want to write, excel at opportunities for writing in this game, partially because they're driven to, they've been given an opportunity to write in ways that make sense to them. And then the last thing is that you can, once you make a game, you can copy the code all of YouTube, cut and paste that, and export your game to any website that may be part of your social community. So it's, again, a way of this idea of cross-channel distribution. So I'm going to do a demo right now real quick. So this is a Gamestar Mechanic website. I'm actually logged in now, and one of the first things that you're able to do is you are given a workshop. And in this workshop, you have a chance to house your inventory and sort of look at your collections. So here I have my resolutions wrong. Here I can look at the original games I've made. I can look at my game jobs, which is my quest structure. And then I can eventually look at my collection of sprites. So anyone can go to anybody else's workshop and take a look. I also have a watch list that lets me pay attention to 5 other designers in the space. So once they make a game, I'm notified, and then I have a chance to sort of track and watch them. And that's a way to create a sort of small sense of community within the larger whole. So this is what the sort of quest map looks like. And here, when you first enter the game, you have only access to one of the cities. The world is made up of 6 cities, which represent the 6 schools of games. And as you level up, you begin to unlock other parts of the map. When I roll over, it shows me how many different kinds of activities I have available to me here. I have 2 kinds of design jobs that I can go on. Design jobs are where I'm repairing or making games, or play jobs where I have to play a game and beat it. One of the big things a game designer does is play a lot of games. So kids actually earn points in this game by playing games and beating them. Once I go into the city, I can make choices about the kinds of arcades that I may want to enter here. So I've already completed this, but I'll just show you. If I open this game arcade, inside of it are 2 different design jobs that I may take on. The dialog box here shows me how many points I can earn. Cogs are a currency in the world, which allow me to sort of earn credits, which I then can take and spend at a store where I can buy rare creatures to increase my ability to design cool games. And then these are the different creatures that, or different sprites that I can collect. So if I click on one of these, it takes me into the editor. And in the editor, the first thing that you're given is an overview of what the criteria for the challenge are. So these are the design constraints. I can do lots of things to the game, but I have to make sure that these 2 conditions remain the same. This is a way to begin to give the kids a kind of language, specialist language around game design, give them the ability to kind of learn what some of the key concepts are. So if I accept the job, this is the screenshot we saw earlier. I've already solved this game. There was a block here. I use my eraser tool to remove it. I also could take this arrow tool and sort of move things around. The game features this sort of button that actually, weirdly enough, doesn't exist in a lot of games, which allows me to toggle back and forth between play and edit. So if I click play, I can immediately sort of test out how my game's doing, sort of move around. If I get to the go block, then I want. There's something called a prove it button in this game, which is you have to prove that you can beat any game that you build or modify. We found early on working with kids that they made really, really complicated games, and so I would be playtesting it, and half hour would go by, and I'm losing and losing and losing, and I would say, okay, you've got to show me how you beat this. And they're like, oh, I haven't beaten it yet. And so then we had this conversation around, so, okay, a game designer doesn't create unbeatable games. Right? They create games that have a lot of challenge, but you have to really think about the level of your player. What are their abilities? What does a first level in a game look like versus a level 50 in a game? And it's led to some incredible conversations with kids, really acting as teachers, designing learning spaces for others. So there's about 80 different quests in the game. And at any point, I can toggle to what we're calling sandbox mode, which is I get a chance to use my collection and build games from scratch. So kids can always toggle back and forth between a sort of scaffolded experience and a more open one. So I'll just build a game here really quickly. The first thing you do in the game is design the space of the game. And the argument for Gamestar Mechanic is not that every game designer thinks about game design in this way, it's that some game designers think about games in this way. So the way that the group that I work with thinks about game design is we often think about, well, what are the qualities of the space that we want to have to create for the game, which then leads us to think about what are the qualities of the kinds of play that might take place in that space. So let's just give this a name. I'll call this Kyle, not sure why. I can choose whether the space is single screen, a scrolling space, or a wraparound space. So let's make it a wraparound space. So wraparound is like asteroids. If I leave one side of the screen, I come back on the other. I can choose qualities of gravity. No gravity is a top-down space like a maze. Light gravity allows me to jump very high, and heavy gravity allows me to jump just a little bit. So I'm going to have sort of between light and medium gravity. I can choose edge bounding. So I have a wraparound space. Should I have it wrap around this way or this way? Vertical or horizontal? Vertical? Okay. So I want to bound my left and right edges. I then have a chance to choose a background. So maybe I'll choose one that's sort of narrative since I'm going to be jumping around. I can choose a soundtrack, and then here I can write an intro message or a win message. Often kids will wait to fill that out until they build a game because they don't really have an idea yet necessarily what they're going to do. If I want to go back to that space, I can just click on level and make modifications. So now I have a kind of space. Over here to the left are my inventory of sprites, and they're organized in 5 different ways. Avatars are player-controlled creatures. Enemies do damage. And all of these creatures have different behaviors. Blocks allow me to build the world. Items are things I can pick up. And system creatures are creatures that sit outside of the game space but watch what's going on inside. So things like a timer, my health meter, a point counter. And with system creatures, you can create complex win conditions. I can say you have to collect all the points and beat the game in under 30 seconds. So let's see, my idea for this game, it's a jumping space, so maybe I want to first test out, well, what do these creatures do? In the beginning, again, kids won't have a full inventory. They'll have maybe one creature. And over time, they learn what the creatures do and sort of build. So I'm going to add this guy, and then I'm just going to click, whoo, okay. So he's falling infinitely. So I probably need to give him something to do. So I may decide, well, I want this to be a game where he's got some ground to walk on. So I can kind of paint with some blocks very quickly. I want to make this look a little bit realistic, so I'm going to give some grass. Sorry, that's always such a funny noise. And then maybe I want to give him some platforms to jump on, because he's sort of in the sky. But then I'm thinking, okay, so it's a wraparound space, and I haven't really taken advantage of that yet. So now I can sort of jump, but it doesn't really matter that I have a wraparound space. So I think I need to sort of revise my decision. So if he can fall, maybe I want to give him a place to fall through. So maybe I'll use my erase tool, and I'll sort of look at where in my game he might have the ability to fall. So now if I have him drop, he can drop infinitely, but whoo, got to move there on the platform. So now there's not really any challenge. I can sort of wander around the world, and we've actually had kids make games that are more like narrative interstitials, where they just tell stories in the game. There's not really conflict that happens, but you move through 50 levels, you sort of look around the world, you may collect some things. But most kids like some kind of challenge, and we would say that any kind of game really needs some kind of challenge. So I'm going to add some enemies, and these guys are pouncers, which means they can jump. And the pacer is one of my favorites. He can move back and forth on platforms. He detects edges. So now I've got a little bit of, okay. I think it's too hard. So I could sort of modify back and forth. Eventually I'll need to add some kind of win condition. I probably want to give him something interesting to do, like collect points. But at any point, if I want to really look deeper into my creature, I can use this wrench tool and click on, again, his sort of dialog box and see his parameters. So here again, I can change his speed, how strong he is, his start direction, turn direction, whether he has babies, all those kinds of things. So maybe I'll make him a little bit faster. Oops, save. And then I can use my clone tool, and I can just copy him, because I think I pretty much love what I've done with him. And you'll see immediately, so he's really fast now. And I can sort of move around. If I want to create a new, level, I can just click here, and then I start again. Level settings, create the space, choose the background. And so one interesting part of this project is that we've been working with kids really since the start. 3 months in, we had what's called an interactive prototype, which was a very rough version of this. We had 5 creatures, there were no backgrounds, they couldn't really modify parameters, but we had the basic architecture of the interface, and we started working with kids, and I ran a 16-week design workshop with 6th and 7th graders, designing games as a way to really learn what it was that they were learning. At the same time, the assessment group from Madison was beginning to try to develop some assessment measures to capture the kind of learning that we were arguing for. So one thing that you guys are discovering is if you're arguing for 21st century skills, things like systems thinking, things like intelligent resourcing, none of the standard measures actually capture that. There's no standardized test that says, okay, a kid really can learn how to think in terms of systems. So part of the work that we're doing, and part of the importance of the work of the Game School, is to begin to argue and develop some new kinds of assessment models that will work in parallel with models that are capturing some of the more traditional literacies. And there's a number of people around the country that are working on this, and we're really building on their work. So over the course of this project, the Madison group has been developing some rubrics around systems-based thinking and using those to begin to analyze and learn what it is kids in fact are learning from this game. So 1 year of research will happen from this point on. This product is in what's called closed beta right now, which means it's by invitation only. And we have about 1,500 kids from 4th grade up until college. I use this in my college classes, developing games. And then the Madison group will be doing research on them over the next year. The idea for the game is that over the next 8 months, it will be built out with new kinds of tools, and will be available for a public release in January of next year. So we're sort of halfway through the project. And I think Jay is going to talk about a game later today, and maybe we'll give some insight again into the kind of length of the development process for these kinds of games. So I'm going to end there, because I want to be able to answer some questions if people have them. I'm also going to be around a little bit later if other people have questions. Again, our work is really trying to look at, what are the conditions for these new kinds of learning environments that we're really trying to build, and how does it leverage, again, the kinds of literacies and the kinds of ways of learning that we're seeing happening in technology-based, often online spaces, situated in lots of different kinds of contexts. So thank you. Is there any questions right now? Yeah.
I have a question. I'm just curious whether you have worked on any games where you allow students to invent the character rather than make the choices. And,
Yeah, absolutely.
And, invent the ways for them to move rather than make those choices that are already given them.
Yeah, no, absolutely. So there's a number of really good game design software out there right now that allow you to design your sprites from scratch. Like Scratch is out there, Game Maker is out there. What we're finding is that those are great at doing certain things, but what they're not great at is getting kids to think about game design. And what we realized is that to sort of move kids into a space where they could be making decisions about the types of characters, about the kinds of behaviors, that we needed first to design a constrained experience for them where they really learned about design.
Right.
So this product was really designed as a partner product for other kinds of game making tools that allow kids to design their stuff from scratch. And lots of people have that question. The kids remarkably never ask that question with this particular tool until they're quite a ways through.
Right.
And part of it is that while it looks like there's not a lot of choice, it's about the combination of choices that lead to a lot of variety. Yeah. So the next thing that we're looking at is what is a curriculum that would connect Gamestar Mechanic with a tool like Scratch that helps bridge this gap between how do you move from a space where you're making design choices within a constrained environment to a space suddenly that's totally wide open, because we have kids sort of flop around in those spaces.
I have a second question.
Yeah.
Are there any games where or at least in your school or something, where there's the development of a sort of social consciousness, because this is in its own sense a sort of a fantasy world. So is there any attempt to bring social problems?
Well, absolutely. So what we're finding, I mean, here's my argument. The way that you frame the making of the game is the way you begin to push on issues like this for kids. So some of the design challenges, we say, okay, your challenge, your design quest here is to design a game about the environment. Now they'll use the same creatures, but the way they narrativize it, the way that they choose a particular sprite to have a particular meaning within that space. So kids are creating socially oriented games all the time with this.
Right.
So and people have talked for a long time like it's really hard to put content into games. It is, but it's not.
Yeah.
It's all about the kinds of meaning that a kid brings to the game, and also the kinds of questions and conversations that they might have with other kids about the game that they've made. So absolutely, and so we're looking at developing a curriculum that maybe looks at some of those specific questions.
Thanks.
Yeah. Yeah, back there.
My question is not related to game design, but I know you work on how technology changes kids learn. I work with adults. How does the new technology affect learning adults who already have learned a lot? And physicians, for example.
Sure.
We are trying to get them to work with technology.
Sure. Are you finding resistance or?
Oh,
yes. Sure. We're always resistant to new things. I mean, the thing with kids, this isn't new. It's like the thing they breathe. So they don't have experience in a system outside of it. We are seeing that adults that have experience with technologies begin to take on the same kinds of learning properties that kids do. And it's just, I always talk about it as a matter of practice. I feel like you get better at anything through practice, and it's a matter of finding ways to invite this group of adult learners into this space in a way that feels comfortable for them. Games in some sense can start to be those kinds of spaces if they're not intimidating games. So we do a lot of, when we work with adults around trying to get them to connect to kid culture, for example, we often start work with non-digital games, things that are very familiar to them from just things that they might do, playing bridge or playing poker, playing more socially based games. And then we begin to talk about, well, what are the ways in which these systems model the kinds of systems that we're then wanting to move them in, whether it's kind of online tools, that kind of thing. So we found it's about making a connection with existing experiences that they might already have that they may not recognize as being quite similar. Does that make sense? So for example, with teachers, when we talk to them about the fact that, well, I'm a game designer and you're a teacher and we do exactly the same thing, that suddenly goes a very long way because now we have a similar language to talk about. If I say, well, how do you sort of differentiate instruction? And they have lots of ideas about that. And then I can say, well, this is the way that the game does it. So let's look at what are some commonalities between those things. Other questions? How are we on time?
No, yeah.
Okay. Yes, I don't know. Do you want to? Okay.
What is the selection process for the new school?
Okay. So the question was, what is the, what is this? Pardon me?
Repeat the question.
Yes, so the question, what is the selection process for the new school? It's a great question. It's actually the first one everyone asks us. So this is a public school. And in New York City, where the school is spatially often has input on that question of admission. So in New York, there are certain districts that are called choice districts. And in a choice district, a kid can choose to go to any school they want to. There's other districts that are neighborhood districts, which means that the school has to be open to any kid in the neighborhood. We ultimately, because we're designing the school, will get to choose some part of the admissions policy, and we have 3 values. One is that we want a school of diversity with the kids, so diverse learning styles, diverse socioeconomic, and diverse ethnically and racially. We want it to be a school of choice, so any kid that goes there should choose to be there. And we also want it to serve the local community. So it's not that we necessarily want to say every kid locally can come, but we want a school that really is embedded in the community that it connects to. So we're working out the details. In New York, the choice system is based on medical matching, so kids will make a list of their top choices. The school had some kind of admission criteria, and then they sort of cross-match those lists. Does that answer your question? Yeah. Yep. Yep.
Yes, did you say Scratch was the name of a good program you want to get into learning?
Yep. Do you know Scratch?
Go on.
Yeah, so an MIT is just around the corner. So Scratch, there's a host of these. Scratch, Squeak, and I think Cricket is a new one. And they're all based on a programming language called Smalltalk. And it really grew out of the group that was working with Lego Mindstorms and visual programming. So kids program games and interactive type things through drag and drop visual programming, building commands like Lego Mindstorms. And in Scratch you can make visual narratives. You can also make game-like things or games. So it's worth checking out. So it's really a software platform.
Are they available web-based?
They're web-based and they're free. Yep. GameMaker is another pretty great game-making tool for really university level. I mean, we've been working with teens, but our undergraduate students use it quite a lot. You have to know a little bit of programming to get in there. GameMaker is built out of the Netherlands, and it has a little bit of a cost, but it also has a curriculum with it if people are interested in checking that out. Other quick questions? Yeah.
It seems to me this process of trial and error, imperfect, and getting feedback and correcting is the antithesis of high stakes testing.
Right.
Have you taken that sort of political stance at all? Are you pushing this as a alternative to what's out there?
We are. I mean, it's tricky. So anytime you need to argue for a new model, you can't not take into account the old model. So some people have said, oh, you should lobby to get out of taking standardized tests. And our argument is, well, we have to actually prove that our kids are doing good or better on those tests, as well as learning some of these other skills. So our model has been that we don't believe in standardized testing, and almost any teacher you talk to will agree. And because of that, we're trying to develop a parallel assessment system. So we'll be evaluating in other ways, with the hope that that's a way to begin slowly over time. It's a long project. Begin to create alternatives for standardized tests, because the problem is there's no alternatives. People say we hate standardized tests, but well, yeah, we don't know what would be better. And so part of our project is to begin to help generate a discussion around that. And again, it's not just us. There's a number of people around the country, and even in other areas. I was talking to someone in Australia the other day, and they have the same conversation going on there. So we may look for some relief from the regime at the upper grades, particularly around the content-based tests, like social studies. Argument would be, well, why do kids need to know those facts? We definitely think they need to take the reading and math kinds of standardized tests, because those are basic measures of what kids need to be able to do. Yeah. Lisa, did you want to
ask a question? Are you finding gender differences in the way students are planning for games? In the past, that was always
Sure. No, it's interesting, and I'm really split on it. I can just give you some anecdotal evidence. So in working with teenagers, boys and girls, we found the only differences in the way they start the design of the game. So the girls that we've been working with often spend a lot of time designing the space. And sometimes they narrativize that. So they're drawing images of things that look like certain kinds of building spaces, or things like teddy bear image sort of faces. The boys, on the other hand, literally fill every single cell with an enemy. Every single cell. They click on the enemy and they're like, enemy, 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 enemy. Okay, then both of them press play, and they realize they don't have a game. And so the process happens, they go in and they start erasing. And then we don't see any differences after that. So it's not just this sort of beginning point. It's fascinating. It's just fascinating. But we found equal parts kids that are driven towards really narrative-oriented solutions. We had a group of girls that weren't using the enemies that shoot. And so the parents we were with were saying, oh, well, that's because girls just don't like conflict, and they don't want fighting games. And so I said, well, let's ask them. And the girls said, oh, well, because it's way too easy if you can shoot the enemy. That's way too easy. So there's all of these assumptions that have really grown up over the years of that girls don't like conflict and boys don't like to cooperate, and we're not finding that that's true at all. We realize that kids are all different, and kids are driven to like certain kinds of play patterns at certain points in their life, and they often shift to different kinds of play patterns. So, but Betty Hayes, who's now at ASU, has been doing a lot of work around gender. So she has, and also Carrie Heater, who is at, I think Michigan State or University of Michigan, has a new online site funded by the NSF around gender studies in games. So that's a great kind of clearinghouse of all kinds of research about that. So, yeah. Okay, okay, sure. Thank you. I just want to do one quick, it was mentioned in the intro that I am one of the co-editors of this new MIT journal called the International Journal of Learning and Media. I would like to give an open invitation to any of you that are doing interesting work with sort of technology and learning to look up that journal. It's an online journal, and we're supporting rich media contributions. So if you're teaching a course in YouTube, you now have a way to actually publish the results of that work because it'll be in an online space. If you just look up the International Journal of Learning Media, MIT Press, you'll be able to get the contributor guidelines and all of that kind of stuff. So it'll launch next year, and we would love to see some submissions from you. It's a peer-reviewed journal,